So hello ladies and gentlemen, my name is Christian Kirchev. I'm one of the software engineers on Genat Pro Compiler. And what I have for you today is a short presentation on Libadalang, or the new generation of Ada tooling. So language-aware software tools are an indispensable part of the development process. They really make our lives easier by ensuring the structural coverage, the structural correctness of a code, or that a particular coding standard has been upheld. So this is why you, the customers and tool partners, and us, AdaCore, need access to Ada parsers and semantic analyzers in order to create these kinds of tools. Let's take a quick look at what solutions are available to all of us that can satisfy our Ada tooling needs. First, we have Genat. This is an excellent parser and semantic analyzer, but as one of the engineers on that product, I can assure you, you cannot build a tool on top of it without costing you your hair and a whole bunch of aspirin. The compiler was simply not designed with that purpose in mind. So Genat is not really a suitable solution for Ada tooling. Next, we have GPS. Our integrated development environment comes with plenty of Ada-aware features such as code completion and code refactoring. Unfortunately, those are not usable outside of GPS. This is because the IDE was designed to drive tools rather than to be part of a tool itself. So GPS is also off the table. The only real solution for Ada tooling is ASIS, or the Ada Syntax Interface Semantic Interface Specification. Good catch there, Ben. ASIS is notoriously heavy. It calls Genat, oh yeah, I see head shaken. It calls Genat to compile the sources. The compiler then saves the abstract syntax tree in a file. ASIS then reads that file, rebuilds the tree in its own fashion, and only then can it answer queries on those sources. In addition, for all of this to work, those sources must be compilable to begin with. It turns out that in certain scenarios, ASIS is kind of an awkward and limiting solution. So at one point, several brave AdaCore engineers said, we can really do better than this. And this is how the Libadalang project got started. The driving motivation behind it is to develop a general-purpose, lightweight, and flexible semantic engine for Ada tooling, which can be used from a variety of contexts, such as code instrumentation, indentation engines, from an IDE, such as GPS, or simply from the command line prompt. So let's have a look at what Libadalang is all about. Under the hood, this is a toolkit which comes with a fast parser, a semantic analyzer, and with the ability to answer queries on the code it processes. So far, this sounds somewhat familiar to what ASIS does. However, the two toolkits differ greatly in the way they operate. For starters, Libadalang does not need a compiler to function. This means no Genat, no GCC. Next, Libadalang can operate on illegal code. This is a huge jump in functionality. Imagine you have an incomplete snippet of code. You will still want to be able to at least pretty print it, or maybe extract some semantic cross-reference information out of it, no? Well, thanks to Libadalang, this is now within your grasp. Operating on illegal code, however, means no semantic checks. And this is fine because the toolkit is not meant to replace a compiler, and it always does a best effort processing on the inputs provided. Physically, Libadalang is a standalone library written in Ada, which also comes with bindings to C and Python. AdaCore's intention is to make Libadalang the prime solution for Ada tooling. Our grand plan really is to unify various Ada-aware tools by substituting their custom language modules with Libadalang. I have listed GPS, GANAT check, and GANAT test here. In reality, this list now amounts to about 10 of our tools. Finally, Libadalang should be available on Windows, Linux, and Mac. So let's take a look at how an Ada tool would use Libadalang under the hood. The context here, let's see, I have a pointer. The context here is an integrated development environment such as GPS. And the high-level task we want to achieve is to right-click on a reference, select Go to Definition, and have GPS jump to that file and line number that contains the definition. You can think that at the lower level, what a tool would do is first start by asking Libadalang to find out what we clicked on. So this is the mouse click, this is a tree lookup. And if the result we got back denotes some kind of a meaningful reference, then we can obtain its definition by simply querying a property. And in the end, we would pass this object up to GPS, and GPS will focus on it. So as you can see, this is a very neat and clean way of introducing a lot of functionality by means of just a handful of lines of code. This is what Libadalang is all about. Libadalang, however, is still under development. The completion date has been set to 2018. Of course, this is subject to change. In parallel to all of this development, the GANAT Pretty Printer is undergoing an active migration from ACES to Libadalang as a form of a usability study. In addition, the GPS team, represented by Nico, has been experimenting with the toolkit very heavily, and they've managed to introduce new functionality in the auto-completion and stubbing portions of GPS, functionality which was previously impossible to achieve with ACES due to various limitations and shortcomings. What you're going to see on the technical front is that the Libadalang team is looking into incorporating code refactoring, something you were interested in, semantic pattern matching, and SQL-like queries as first-class citizens in the technology itself. They already have a version of code refactoring working, which I will now show to you. The context is, again, an integrated development environment such as GPS. This time around, though, we would like to click on a reference, rename it to something else, and have the associated definition and any other references to it be automatically updated. So notice this is not a textual substitution, this is really semantic substitution. So what a tool would do at the lower level is, again, start by asking Libadalang to find out what we clicked on. This time around, though, we will use Libadalang's cross-reference engine to rename the definition directly. This action automatically updates all references to that definition. Again, very, very convenient and elegant way of Ada tooling. So what I'd like you to take away from this presentation is really this slide. So for you, Libadalang means a fast toolkit for Ada tooling. It's fast because it doesn't depend on any of the tools, including a compiler, and it's smart enough to reparse and reanalyze only sources that have undergone changes in a large set of files. Libadalang has various operational modes. You can focus on only syntactic queries, if you like. You can do semantics, or you can go a step further by asking, is this type limited? Give me all the formal parameters of this subprogram, and things like that. The semantic engine underneath all of this is very flexible because it can operate on any code, including illegal code, from a single file to a whole, potentially large project. Libadalang also comes with plenty of features, such as the various lookups that you saw. In addition, we have the code refactoring and the cross-reference engine. All of this is available to you for use from Ada, C, and Python for some quick prototyping, or if you'd like to create an industry-grade tool in whatever context you find relevant or meets your needs. What you're going to see from us in the future is just a general improvement of the quality and performance of our AdaCore tools thanks to the benefits that Libadalang brings. In addition, the architecture of the Semantic engine will allow us to better, I should say, provide a more timely support for new versions of Ada and Spark 2014 in order to satisfy our growing needs for Ada tooling. So I hope you've enjoyed this really quick look at Libadalang, and with that, I leave you in the hands of Albert for some bare metal mayhem.